Have you ever really thought about that invisible force that holds a magnet to your fridge, or the one that guides a compass needle through the middle of nowhere? It's all around us, all the time, and it's called magnetism. And today, we're going to pull back the curtain and see what this mysterious force really is.
So, let's start with something we've all seen, right? A simple compass. That little needle inside is just a tiny magnet, and it will always swing to point north. It's lining itself up with this massive, unseen field, a force that wraps around our entire planet. So the big question is, what's actually going on here? I mean, what is this force that can reach through empty space and make things move? Let's dive in and find out. Okay, first, we're going to look at the stuff we can actually see and touch, the kind of magnetism that feels, well, a little bit like magic you can hold in your hand. That exact same force that guides the compass is what's happening right here. It's what lets a magnet pick up a bunch of nails without even touching them, or, holds that grocery list onto your fridge. It's all about an interaction between the magnet and the metal. And this isn't some new thing we just discovered. People have known about these weird, magic rocks for thousands of years. The ancient Greeks actually found them near a place called Magnesia. And yep, that's exactly where the name magnetism comes from. Now, if you look at any basic magnet, you'll see it has two ends. We call one the North Pole and the other the South Pole. And this little detail, it's the absolute key to understanding how all magnets work.
And the rules are super simple. It's like this: opposites attract. A North Pole will always pull toward a South Pole. But what about two of the same, like poles? They push each other away. If you've ever tried to force two north poles of a magnet together, you've literally felt that invisible cushion of force pushing back. Okay, here's where it gets really interesting. You might think, I know, I'll just snap this magnet in half and I'll get a north pole all by itself. But you can't. It's impossible. Nature just won't let you. When you break a magnet, you just end up with two brand new, smaller magnets, and each one has its own north and south pole. You can never, ever get a single pole by itself.
So we have these poles, north and south, but how do they push and pull on each other from a distance? Well, they do it through something called a magnetic field. Now, let's take that idea and scale it way, way up, like to the size of our entire planet. Believe it or not, our whole planet acts like one gigantic magnet. It creates this huge magnetic field that surrounds all of us. And that compass needle we started with, it's just a little magnet that's lining itself up with Earth's massive field lines. Now, get ready for a little bit of a mind bender. We just said that the north pole of a magnet is attracted to a south pole. So, if the north pole of your compass points to the geographic north pole, what does that mean? It means that, magnetically speaking, what we call the North Pole is actually a magnetic South Pole. Wild, right?
For centuries, this was all still basically magic. Nobody knew where this force actually came from. But the answer, it turns out, was hiding in a totally different part of science: electricity. This is it. This is the big secret. This one idea changes absolutely everything. Magnetism isn't its own separate thing. At its very core, it's just what happens when electric charges start moving around. And this didn't happen overnight. For thousands of years, it was just about those magic rocks. But then, in 1820, everything changed. A scientist named Hans Christian Ørsted was in the middle of a lecture, and he noticed that when he ran an electric current through a wire, a compass needle nearby twitched. That was the moment, the aha that connected it all. And today we know that all magnetism, from your fridge to the center of the Earth, is caused by one thing: moving electrons. So this deep connection gives us a whole new word for it: electromagnetism. See, they aren't two different forces. They're two sides of the exact same coin. A moving charge creates a magnetic field, and a magnetic field pushes on a moving charge. Now, once you realize that it all comes from moving charges, things start to get pretty weird. Because the force that magnetism creates, well, it doesn't behave like anything you'd expect. Let's just compare them for a second. An electric force is pretty straightforward. It'll push or pull on any electric charge, doesn't matter if it's sitting still or flying past. But the magnetic force, it's picky. It completely ignores a charge that's just sitting there. It only kicks in when a charge is moving. No motion, no magnetic force. That's the rule. And here is the truly bizarre part. The magnetic force doesn't push in the direction the charge is going, and it doesn't push in the direction of the magnetic field lines.
It pushes sideways to both of them at the same time. It's this weird, three-dimensional right-angle force that's just not intuitive at all. So how on earth do you figure out which way this sideways push is going to go? Well, physicists have a clever trick called the right-hand rule. You can try it with me. Take your right hand. Point your fingers in the direction the charge is moving. Now curl your fingers in the direction of the magnetic field. Stick your thumb out like you're giving a thumbs up, and boom! Your thumb is now pointing exactly where the force is going. It's a neat little trick to solve a 3D puzzle. Okay, I know all this talk about invisible fields and weird sideways forces can feel super abstract. So, is there any way we can actually see what's going on? Well, we can visualize it by drawing something called magnetic field lines. Think of them as a map of the magnetic field. They always flow out of north poles and loop around into south poles. And the closer together the lines are, the stronger the magnetic forces is in that spot. And this is where it gets so cool. We can draw these lines based on math and theory, but check this out. What happens if you just sprinkle tiny little bits of iron around a magnet? They automatically snap into place, tracing out the exact same patterns. The invisible is literally made visible. It's amazing. So let's bring it all home. That mysterious force that guides a compass, the everyday magic that holds things to your fridge, and the powerhouse force that runs our electric motors, it's all the same thing. It's all just a consequence of the simplest thing you can imagine, a tiny electric charge moving. So I'll leave you with one final thought to chew on. We've just learned that all magnetism comes from moving electric charges. And our own bodies, our brains, our nervous system, they all work by sending tiny little electrical currents around. So, what does that mean about us? Are we magnetic? Something to think about.